All right, so let's look at lesson 68, more about complex fractions. Now, you guys have used complex fractions before in Saxon Algebra 1, but they're wanting to go deeper. So one thing we've done is we also understand that anytime I'm adding or subtracting fractions, my denominators have to be the same. We've also done some that had a fraction in a fraction, and so that was a little bit more complicated. So if you take a look on page 276, it kind of talks you through what do I do with variables in fractions, different things. Now, it shows you on page 277, the top, it says simplify. And you'll notice that everything is over y. Well, that makes life a lot easier, doesn't it? So please follow me along in your book on page 277 at that example, because this is super important since they're complex questions. So if I have x over y plus 1 over y, they're both over y, so it would just be x plus 1 over y. Then the denominator part of this fraction says x over y minus 1 over y. Well, since they're, again, both over y, then I just bring that y over and then combine the numerators. Now, one thing is that I want you guys to understand is that whole keep, change, flip. If I'm dividing a fraction, it's really like multiplying its reciprocal. So that's what they did there on the next part. And if you flip the second, you're going to have y over x minus 1. Well, when that happens, the two y's cancel each other out. So you're simply left with x plus 1 over x minus 1. Isn't that so much more beautiful? You know, what's exciting is sometimes something that looks so complex, when you just take it one step at a time, just like a big juicy steak, one bite at a time, you can truly enjoy it. Now, if you look on page 277, 1 over 1 plus x over 7. Well, let's take it one bite at a time. The numerator. I've got to get common denominators. So I've got to convert 1 to x over x because that reduces to 1 whole. Well, then that would end up being x plus 1 over x. And then that whole thing is divided by 7. Well, if I keep, change, flip, and I flip, it would be 1 over 7. So then I'm just going to multiply numerator, numerator, denominator to denominator. Final answer on 277 is x plus 1 over 7x. Now, your book kind of shows you in a more complex way than what we tend to do when we just keep, change, flip. So, but they're doing the exact same thing that we've talked about. Now, if you'll turn to page 278, page 278 has a little bit more complex, and then it has a few practice problems. So let's jump in there. Practice A. So practice A says 1 over W plus C over W, and the whole thing is divided by 1 over C. So if you would write that down. All right. So we're working on this complex fraction. It's practice A, page 278, lesson 68, and this is practice A. Now you'll notice right from the start that I have both denominators are W's. So that makes life so much easier, doesn't it? It's simply 1 plus C over W. My denominators were the same, and I just brought the denominator over, and then I combined the numerators. Now, the numerators are not like terms. 1 and C are not like terms. So what can I do? I just have to keep them separate. Now, it's still divided by 1 over C, right? It's my fraction there. Well, how about keep, change, flip? So I keep the first one the same, keep, change the divide to multiply, and then flip C over 1, right? So now that I've keep, change, and flip it, then all I have to do is distribute the C to both parts of this. It's an understood parentheses here, so the C has to go to both parts. So it's going to be C plus C squared over W. And that's my final answer. My final answer, because I distributed that to both parts, There's nothing more that I can do. And so that is practice A. W just is the new denominator. All right. Now let's take a look at practice C. And I'm going to give you a moment there on practice C. So if we take a look at practice C on lesson 68, one thing that the book does is it starts out with negative exponents. Does everybody see that? It's negative exponents. So I took a few moments, and instead of just keeping them negative exponents, it's a little bit easier to take time to convert those to fractions. Doesn't that help a lot, just to see them as fractions? Now, the difference between practice A and practice C, practice A, they were nice and gave us common denominators. C, not so much, right? So what do we have to do? We have to get common denominators. So my common denominator is going to have to be xy and xy. So I've got to now change my fractions to have xy. So the first one didn't have a y, so I'm going to multiply y by both. So that would be ay. My second didn't have an x, so I'm going to have to distribute an x to both. So that would be bx, right? So I've got ay over xy plus bx over xy. All right, now I've got a common denominator. So my common denominator would be xy, and then I've got ay plus bx. Sorry, that's a little bit messy. But that whole thing is over 1 over x. Notice I just brought that down, right? So I think that's super important that we're able to see. I was just rewriting the numerator, and I realized it kind of looks like I left out the denominator, right? So in doing that, now I can keep change flip. So let's rewrite it. Ay plus bx over xy. Keep the first part the same. Change it to multiplication, and then flip. Well, the nice thing is when I flip it, the x's are going to cancel out. One's in the numerator, one's in the denominator. They cancel each other out. So all I'm going to end up with is ay plus bx over, the only thing left in my denominator is 1y. That's it. So that's my final answer. That's all that's left. Now, isn't that amazing that it took an ugly fraction up here with negatives and everything, and just a few simple steps, we reduced it and we made it much, much easier. So I hope that that's an encouragement to you. So big difference between practice A and practice C. All right, my friends, I want you to gear up with an extra special smile, because our next lesson, lesson 69, is my absolute favorite Algebra 1 lesson in the entire book. Now, I know you're saying, Miss Kim, is this true? Friends, I love factoring like none other. Now, it's easy to get overwhelmed with factoring and think, but I've never done this before. You know, in algebra, we've looked at a lot of inverses, haven't we? The inverse of addition, subtraction. The inverse of multiplication, division. The inverse of squaring is square rooting, right? Well, we've already learned how to FOIL, and we call that binomial multiplication. First, outer, inner, and last. Well, what's the inverse of that? I'm so glad you guys asked me that, because that's what we're learning today is factoring trinomials. We're going backwards. What if I gave you the answer to binomial multiplication and said, hey, what are my factors? You would have to go backwards from FOILing. So this is a little bit different. Now, your book shows you a neat little chart on page 280. And it shows you how to break down. So if we look at the vertical format of two binomial factors, x minus 6 and x plus 3. And your book shows first, outer, inner, and last. Now, we tend to write it this way, x minus 6, x plus 3, right? We tend to write it horizontally. Your book is showing you vertically how to write that. Now, you all understand that what I did is I distributed the x to both parts, first, outer, inner, and last. And that's how I did binomial multiplication. We called that foiling, right? Well, this week, we're actually looking at how do I go backwards? How do I factor? So one thing I want to encourage you guys with is it just takes practice. Just like riding a bike, the first couple of times it's going to feel a little bit wobbly. Keep trying. Don't give up on me, okay? But there are some simple rules to follow. If you'll look at the bottom of page 280, it goes over some of those simple rules. The first term of the trinomial is the product of the first terms of the binomials. So one thing you want to do is always make sure that before you start trying to factor, that everything is in the correct order, meaning highest to lowest degree. And you want to make sure your leading coefficient is always positive. If your leading coefficient is not positive, then you need to take out a negative so that you can factor. So it needs to go from highest to lowest degree, squared, and then to the first degree, and then your constant. Always that order. That's why we learned that previously. And then after that, you need to make sure that your leading coefficient is positive. If it's not, take out a negative so that you can solve. All right. Now let's take a look at page 282. It shows you some of the things that you're factoring. And what you're going to have to do is remember back. Do you all remember in second and third grade when you started memorizing those multiplication tables and you thought, oh, am I ever going to use that? Oh, my friends, those multiplication tables are going to come in super handy right now. Okay? So let's take a look. One thing that I want to do is I want to do some of the practice problems with you. So if you'll look on page 283, we're starting with practice A. Practice A says x squared minus x minus 42. All right, so this is, we're looking at a trinomial, and it goes in order, x squared, then x to the first degree, and then my constant is negative 42. So I go in order. Now, there are some things that I always have to ask myself first. Is it in the proper order? Yes. Is my leading coefficient positive? Yes. X squared is positive. Now I'm ready to factor. Now, how do I factor? I look at my last sign first because there's clues. I don't know about you guys, but I loved when I was younger reading detective stories. I love Nancy Drew and the Hardy Boys. There's always clues to help those detectives solve things. Well, there's clues in solving for this. So the Bible says the last shall be first. So we go to the last sign first. So the negative sign tells me that they are different. Now, if it were positive, it would tell me they're the same, and then you would look at the next sign to see what they're the same of. In this case, it's a minus, so that means that they are different. So that means my middle terms are going to be different, so I can come down here and I can automatically factor. And I'm going to put one positive and one negative. Miss Kim, how did you know that? Because this sign told me they're different. Now, the greater absolute value is going to go with the negative because my middle term is negative. This tells me they're different. If it were plus, it would be the same. And this tells me the greater absolute is going to go with the negative. Now, because my first is just x squared, the leading coefficient is 1, I just have to break apart the ones. So this would be x and x. Does everybody see where I got that? X and x. So I broke apart x squared and I put x and x in my two binomial factors. Now, what I've got to do look at are the factors of 42. What are the factors of 42? Well, 1 times 42. It's even, so 2 times 21. 3, will 3 go in? 3 times 1, 14. 3 times 14. 4 won't go in. 5 won't go in. 6, yes, 6 times 7. And then they meet 6 and 7. So I did it in order. 6 and 7 meet. So I know these are all the factors of 42. Now what I have to do is look for one that when they subtract it makes 1. Well, 42 minus 1 is 41. That's way too big. I'm going to mark it out. 21 minus 2 is 19. 14 minus 3 is 11. 6 minus 7 is 1. friends, I found my two factors that subtract and make 1. Now here's my dilemma. Which one goes with which? Well, because it's a negative sign, 7 gets to go with the negative. He wins. 6 goes with the positive. Now, here's the beautiful part about factoring. You can always check your answer. I'm going to go a step further. You should always check your answer. You know, have you ever wished, like when you got through with something, you would say, maybe you took a English test and you'd say, oh, I wish I knew what my grade was. Well, you know, the great thing about math is you can check. Did I get the right answer? Check, and you'll know. So what can I do? I can FOIL to check. X times X, X squared. X times negative 7, negative 7X. 6 times X, positive 6X. Minus 6, positive 6 times negative 7 makes negative 42. Combine these two terms, X squared minus 1X minus 42. Friends, this is the same as this. So, did I get the right answer here? You bet. So, do you see that even though it's a little bit more complicated, I can always check? All right, I want you to take a look at practice B. Practice B is a little bit different than practice A. How's it different? It says the same thing. X squared plus X is the only difference. So everything is the same from A to B, except the middle term is a positive X instead of a negative X. Well, friends, what does that mean? Well, let's go back to what we learned. My leading coefficient has to be positive. They have to be in the right order. This sign tells me they're different, so I'm going to break that apart. I'm going to break apart the X's. And then this time, because it's positive X, that means that the 7 has to go with the positive instead of the negative like up above. So they just switch the two. Now let's FOIL to check. X squared minus 6X plus 7X would give me plus 1X, or plus X, same thing, minus 42. So do you see that I actually checked that one in my head, but nonetheless, I would encourage you check. In fact, if you all take assessments and you miss it, you might see me write a note and say, did you check? Because I can tell typically if you checked or not, whether or not you got the right answer. So this is a new concept. It's unusual, but the great thing is you can check it and see how you did. All right. Now, let's take a few moments and let's jump into practice C. Practice C is a lot different than practice A and B because it's different terms. All right, it still has a negative at the end, so we're still dealing with different signs. So practice C, I'm still on page 283, X squared minus 6X minus 16. Now, I hope you're getting up on that bike. I know it's a little bit wobbly because we just started, but we always want to check. And I know right now you're saying, Miss Kim, it's always in the right order. Friends, as you get deeper into algebra, they're not always going to... As we get into this even deeper, there is going to be times that they mix up the order. So I am so sorry if you get in the habit of not checking that order, because later on it will swap around. So you got to watch the order. It's the highest degree, then X, then negative 16. All right. So I have it in the right order. My leading coefficient is positive. And even in Algebra 2, there are going to be times that the leading coefficient's not. So that's why it's important to check. So what do I look at first? The Bible says the last shall be first. So look at that sign. That sign tells me they're different. So I'm going to write one positive, one negative. It does not matter if you write the first one negative and the second one positive. Doesn't matter. I just have a habit of going plus then minus. I'm going to break apart the X's. What really matters is the number you put with the positive and the negative. Now, because they're different, they subtract to make 6. So I've got to look at the factors of 16. 1 and 16, 2 and 8. 3 does not multiply, but 4 times 4. Now, I know it can't be 4 times 4 because 4 minus 4 is 0. 1 minus 16 would be 15, so it's got to be 8 minus 2 is 6. So do you see how just writing out my factors helps me to solve it? All right. Now, because it's negative, I'm going to let 8 go with the negative because it's negative 6. If I put the 2 with the negative, it would end up being 8 with the positive, and that would be 6 positive instead. Now remember, we always FOIL to check. X squared minus 8x plus 2x would give me more negative than positive, so that would give me negative 6x minus 16. Friends, we have factored it correctly. And you know what? There's going to be even more fun that we do with these as we progress in time. Now, if you'll notice on page 283, questions 13 through 18 tells you to first rearrange it in the proper order, then factor. So do you see why I'm teaching you to follow that order? Okay? Take a look at question number 17. Question number 17 tells me they're not in proper order. It's x squared plus 27 plus 12x. And the problem here is that I've got the constant in the middle. So it should go x squared, then x to the first degree, then your constant. So let's rewrite it. X squared plus 12x plus 27. Now, my leading coefficient is positive, so I'm good to factor. Now remember that we said descending order and then leading coefficient positive. When those things are done, then we can factor. So what do I look at? Well, the Bible tells me the last shall be first. So I look at the last sign first. That tells me they're positive. Friends, since they're positive, it means they're the same. All of the ones that we factored before have been different, so we had to have different signs. This means they're the same. Then you go to this one and it tells you what they're the same of. So in this case, they're both the same of positive. Same of positive. Break apart your x's. Now I'm looking for the factors of 27. Since they are the same, whether they're the same of positive or the same of negative, they'll add to make the middle. See, when they're different, they subtract to make the middle. When they're the same, they add to make the middle. What are the factors of 27? 1 and 27? Well, that would add together to make 28. That's too big. 2, nope, it's not even. That won't work. 3 and 9. Oh, that's it. 9 plus 3 is 12. So I can put either one. It doesn't matter whether I put 3 first or 9 first. It doesn't matter. But I can FOIL to check. 3x plus 9x makes 12x. And then 3 times 9 is positive 27. Now, I promise the more that you do this, the faster that you'll, quote unquote, see it. You'll think of what factors it can be. Because I immediately knew they've got to be closer together, because 27 and 1 make 28. That's way too high. All right. So that was question number 17. Move with me to question number 18. Question number 18 says x squared plus 90 minus 19x. All right. Did you catch it? Did you catch it? It's out of order. So I hope you're watching that there. So x squared minus 19x plus 90. All right, now it's in the proper order. X squared to the first and constant. It's in the proper order. My leading coefficient's positive. Then what do? I look at the last sign first. The last sign tells me they're the same. Same of what? My friends, this time they're the same of negative. Now I separate the x's. And I know that I'm looking for the factors of 90. Sorry. All right. Sadie's saying good morning. All right. So the factors of 90 that will add to make 19. Now, you know 1 and 90 is way too big. 2 and 45 is way too big. So I know that it's going to have to go a lot further. And I know 9 times 10 makes 90. And that also adds to make 19. So 9 and 10. All right. So I know that it does not matter whether I put 10 here and 9 here. It doesn't matter which one. You know, just like factors, if I say 2 times 3 or 3 times 2, it doesn't matter. The answer is 6. All right. So these are the factors. Sadie. I'm super sorry. Sadie is being our guard dog right now. And we have a neighbor that's walking, so she just wants to say good morning. All right, so this is my answer. Let's FOIL to check. X squared minus 10x and then minus 9x would together make minus 19x. But then notice here, a minus 9 times a minus 10 is going to make positive 90. And that's where the same of comes from. So we FOILed a check in our mind and we made sure that it is the correct answer. Now, friends, I know that lesson 69 is a little bit intimidating because it's new. Anything that's new to us, our brain says, oh, it's new, it's new. But I encourage you, the more that you practice it, the more, just like riding a bike, you're going to be just riding along and feeling super, super comfortable. So please don't be overwhelmed or discouraged. I hope you guys will have a great attitude with the new concept. Now let's jump into lesson 70, probability. I love probability. I told you that this week is one of my favorite weeks in algebra. So probability is very simple. It's just the desired over the total. All right. Now, a lot of people think when I start teaching probability, they say, Miss Kim, are you teaching us to gamble or to bet? Absolutely not. If you knew the probability of going down to the store and buying a ticket, what is that called? The lottery, sorry. Obviously, mathematically, it doesn't make sense, so I don't do it. All right. Now, I want to encourage you guys that if you look on the board or if you see a TV commercial and it says the Virginia or the Tennessee lottery is now, 80 million, and it says all that at the very bottom, whether you're hearing a commercial or you're seeing it on a billboard, they are required to tell you the probability. And the funniest thing is that probability, it'll be like 0.00000000001. Well, you guys know it means like out of 1 trillion different tickets, you might have the winning one. So the probability is very, very slim. Yet, unfortunately, some people that, especially if you don't understand the math, people go to casinos, they go buy lottery tickets all the time with these high hopes of not understanding the mathematical advantage is definitely not in their favor. Maybe you've heard that in casinos like in Las Vegas that the house always wins. There's a reason that those casinos are so glamorous and so nice is because the advantage, the probability is in their favor, not in yours. So basically, if I have a coin and I say I'm going to flip a coin. Now I don't have a coin, I'm holding a magnet, but one side has the magnet and one side is red. If I flip it, what's the probability it will land on the magnet face up? Well, it's the same as a coin. You just have two options. So it would be 1/2, right? So there's one desired outcome I have, and there are two total possibilities. So 1 out of 2 is the probability there. All right. Now, your book also shows you how about rolling a dice. Well, rolling a dice, there are 6 sides to that dice. So if I say, what's the probability of rolling a 5? Well, I desire 1. And I have a total of 6 different sides on my dice. So that is 1 out of 6. So that is my total answer, is 1 out of 6. All right? Now, if you'll turn the page to page 286 and 287, it will show you all different kinds of probability. All right? Now, it actually shows you if you roll a dice 2 times. Like, what's the probability that you'll roll a 1 the first time and then roll a 1 the second time? Well, so they show you that probability on the bottom of page 285. It's super neat. All right. Now, look on page 286, and it shows you if you toss a coin, heads or tails. How about the second toss? Well, your book shows you that, what's the probability of getting heads? Well, your book shows you the whole picture there in the middle of page 286. That's your little chart. But you all could just go 1/2 times 1/2, right? So it would be 1/4 because each outcome is separate, right? Whether I roll head or toss a heads the first time has little outcome on the second, but I multiply it together. So to get heads, the probability would be 1 out of 4 options, right? Okay, now there's a lot of practice on page 287. A fair coin is tossed 3 times. What is the probability it will come up heads all 3 times? Well, I've already done it twice, so 3 times I would just multiply it. 1/2 times 1/2 times 1/2. So it would end up being 1 out of 2 times 2 is 4 times 2 is 8. So it would be 1 out of 8. So the probability is 1 out of 8 different options that will come out. All right. Letter B, a single die is rolled 3 times. What is the probability that the next roll will produce a number greater than 3? Friends, it doesn't matter that it's been rolled 3 times before. That does not determine the outcome of at the end. So what is the probability the next roll will be a number greater than 3? Well, let's think of the options. It can be 1, 2, 3, 4, 5, or 6. So to be greater than 3 means I desire it to be 4, 5, or 6. So I have 3 different possibilities that I want it to be, but there are 6 total. So my probability is 1/2, right? Anything over 3, right? So anything over 3 is 4, 5, or 6. All right? Now, let's look at number 4. The spinner shown is spun twice. What is the probability that the spinner stops on 4 and then on 1? So let's think about that for a moment. Again, probability is desired over total. Desire over total. So I desire it to land on 4 the first time. So that would be 1, and there are 4 total. So 1 over 4 is the first, and then I want it to land on 1 the second time. Well, that's another 1 out of the 4, right? 1 out of 4. So those are 2 separate events. Doesn't matter what it lands on the first as it lands on the second. And it's not like it can't land on 1 and then 1, right? So my answer would be 1 out of 16 is my total probability. All right. I was doing question number 4, not practice. I'm sorry. I saw the spinner in the practice and then I just jumped down. So this is question number 4. I'm sorry, friends. I was just excited about that. All right, let's go back up to practice D. All right. Practice D says an urn contains 6 pink and 7 blue marbles. A marble is drawn and dropped back into the urn. So that means that none have been taken out. If one was drawn and then dropped back, it's still back to the original. The second marble is drawn and dropped back into the urn. Both marbles were pink. All right, so what's the probability that both were pink? Well, there are 6 desired over 13 total, and that happens twice. So my answer would be 36 over, and I'm not sure what 13 squared is. I don't have my calculator, but you guys can do that at home, and then don't forget to reduce it if you can. Now, so that's all you're doing is desired over total, all right? Now, it then says another question. If another marble is drawn, what is the probability that it will be pink? Again, you do the same thing. 6 out of 13, and you multiply it 3 times. All right? We have one more lesson, and lesson number 71. So we did 67 the previous week. So it's 68, 69, 70, and 71. All right? It says trinomials with common factors. So that is just taking out what's in common first, and then you can factor it. Or in this case, if the leading coefficient is not positive, then you're going to have to take that out. All right. And then also they are showing you how to use subscripted variables to use substitution or elimination. You'll do this a lot in Algebra 2. So that's why it's super important. All right. I'm sorry, you guys. If you'll look at question B on page 290, we only have a few minutes left. But if you'll look at question B, it says negative x squared plus 24 plus 2x. First of all, it's out of order. All right. So if I put it in the proper order, negative x squared plus 2x plus 24. All right, it's out of order. Then I've also been reminding you my leading coefficient has to be positive. In this case, it's not, so I'm going to take out a negative. That means every sign inside has to change. X squared minus 2x minus 24. Now I can factor. I am going to bring down my negative, and then I'm going to remember that the last sign goes first, and that tells me they're different. I'm going to break apart my x's. And then I have to think of the factors of 24, and I hope you guys are getting a little bit more confident in this. The factors of 24 that would subtract, since they're different, they have to subtract. And this time they need to subtract to make 2. Well, that would make 23, that would make 10, that would make 5. It has to be 4 and 6. Now, which one goes with which? Well, I've got 4 and 6. Well, 6 has to go with the negative. So that is my final answer. I factored it, and I can FOIL to check. X squared minus 6x plus 4x would make my negative 2x minus 24. All right, so that's a great practice. We did not practice the substitution with the subscripted variables, but again, it shows you how to do it, and you're just plugging it in just like you did substitution before. All right, so practice A on page 290, and it is negative 4x cubed minus 28x squared minus 48x. Now let's start out by asking ourselves, is it in the right order? I've got exponent 3, 2, and then 1. It is. My leading coefficient is not positive, so I need to take out a negative, but did you notice that everything has something in common? It has an x in common. So you're looking for your GCF. What can I take out? So I can take out a negative x and then 4. Will 4 go into all of these? Yes. So I can take out negative 4x out of every single part. So let's do that. So let's take out negative 4x, and that leaves me with x squared. Now let's take out negative 4x here. That would give me positive 4 times 7 is 28, so positive 7x. I'm taking out a negative 4 out of negative 48, so that would leave me with positive 12. Now, one thing I do is I always distribute back to make sure, do I have this in the right order? So it'd be negative 4x cubed minus 28x squared minus 48x. Yes, I distributed back in my mind to make sure, do I have the correct answer? And I want to encourage you guys, always verify, always check. Don't just assume you've worked everything correctly. There have been so many times I have worked something all the way down and then realized I missed one sign, and that one sign affects everything. Now I'm going to bring down the negative 4x, and then I'm going to factor. Now, remember that my leading coefficient is positive. I look at my last sign first. This tells me they're the same of plus. So I'm going to write plus plus, right? I'm going to break apart the beginning x squared, and that's just going to be x's. Now, since they're both the same, I'm looking for the factors of 12 that add to make 7. I know it can't be 1 and 12. That adds to make 13. So 2 and 6, that adds to make 8. 3 and 4. Friends, we found it. 3 and 4 make 7. So it's going to be 3 and 4. Verify to check. X squared plus 4x plus 3x makes 7x plus 12. We've got it. So now we factored and we're finished. All right. Now I do want to draw your attention to letter C and letter D. Now letter C, it's already set up for you. They isolated n to the q. So you just plug in n plus 5 for n to the q. But don't forget, you're going to have to multiply 24 to both. Now on letter D, it would be very easy to distribute a negative 6 to the second one and then eliminate. So that's all that you're doing. It's just that they've given you subscripted variables instead of x and y. So everything in this lesson you have done before. All right. I hope y'all have a great week.